What if I told you there's a black hole so massive it defies imagination? A cosmic giant lurking in the universe minus 66 billion times the mass of our sun. What would happen if you got near it? Could anything survive its pull? Black holes are already among the most powerful and mysterious objects in space. But some of them are so unimaginably huge that they reshape everything we know about gravity and the universe itself. Today, we're diving into the world of this record-breaking supermassive black hole, where physics is pushed to its absolute limits. Let's begin. Before we begin, support Beyond Earth by liking and subscribing. Thanks for exploring the universe with us. In the vast universe, few objects are more mysterious than black holes. They cannot be seen directly, yet they ravenously consume everything around them. Some black holes are unfathomably massive, capable of swallowing entire stars and interstellar matter. As more matter falls in, they can grow almost endlessly. To truly grasp their nature, we must first understand the power of gravity. Imagine throwing a ball into the air. It rises, slows down, and then falls back. This happens because Earth's gravity pulls it back. Similarly, for a rocket to escape Earth's gravity, it must surpass a critical speed, the escape velocity. For Earth, the speed is 11.2 kilometers per second. But what about a black hole? Its escape velocity equals or exceeds the speed of light. And in physics, nothing can travel faster than light. So once something crosses a black hole's event horizon, even time itself is trapped. Any matter that enters this boundary is lost forever. But if black holes don't emit visible light, how did we even discover them? Though they seem like voids in space, black holes have a profound impact on their surroundings. Their immense gravity pulls and compresses incoming material, forming a blazing accretion disk. Gas and dust in this disk spin at incredible speeds, creating friction-induced heat that emits powerful X-rays and gamma rays. Using space telescopes and satellites, scientists detect this high-energy radiation, revealing the presence of black holes. But that's not all. Black holes also distort space-time, influencing nearby stars. If a star exhibits strange orbital motion, it could mean an invisible giant lurks nearby. In theory, any object can become a black hole if compressed to an extreme density. For example, if you wanted to turn the sun into a black hole, you would need to compress it to a radius of nearly 3 kilometers. And if you wanted to turn the Earth into a black hole, you would need to compress its entire mass into a tiny space, less than 9 millimeters in diameter. It's a sphere the size of a soybean. So, could such a tiny black hole really exist? In theory, distant black holes may have formed in the early universe. Some of them are as small as atoms. What if these black holes existed? Their temperature would be extremely high, even higher than that of the sun. They would eventually evaporate in a very short time. So these kinds of black holes would not have a significant impact on the cosmic environment. Some scientists have even proposed hypotheses suggesting that primordial black holes could be one of the components of dark matter. But this idea is still being explored. Putting assumptions aside, astronomers have solid observations of stars and black holes. Such black holes are formed by the violent explosion of massive stars, also known as a supernova. Deep in the universe, when a star runs out of fuel, its core collapses, triggering a violent supernova explosion. The brightness of this explosion can even surpass that of an entire galaxy. The black hole was born in the aftermath of this cosmic storm. To measure objects in the universe, scientists use the mass of the sun as a unit. The mass of the sun is approximately 1.9 times 10 to the power of 30 kilograms. Typically, the mass of stars and black holes ranges between 3 and 10 solar masses. Humans confirmed the existence of a black hole for the first time with Cygnus X1, a stellar black hole in the Milky Way, located about 7,000 light-years from Earth. This black hole has a unique feature: it rotates extremely fast. It spins at an incredible speed, nearly reaching the theoretical maximum 800 revolutions per second. Although it has a mass of 21 solar masses, it is still considered small in the black hole family. Above stellar black holes, we have even more massive ones, intermediate mass black holes. This type of black hole has long been a key focus for scientists exploring the evolution of black holes. However, evidence has been sparse. In recent years, astronomers have discovered several objects that may belong to the intermediate mass black hole category. In 2006, astronomers detected an unusually strong X-ray signal in a dense star cluster outside the Milky Way. Based on its brightness, they estimated its mass to be about 50,000 times that of the Sun. Although we cannot yet determine its exact nature, its characteristics fit the criteria for an intermediate mass black hole. However, with a mass of 50,000 times that of the Sun, it is still insignificant compared to supermassive black holes, true cosmic behemoths. Supermassive black holes are commonly found at the centers of galaxies. This black hole has a staggering mass of 4.6 million times that of the Sun, yet it remains relatively compact. Its diameter is only 17 times that of the Sun. In other words, its actual size could fit within Mercury's orbit. Although it is about 26,000 light-years from Earth, far beyond our reach, it remains one of the dominant forces in our galaxy. Deep in the universe, even more massive supermassive black holes exist. Some of them are truly bizarre. For example, NASA's Hubble Space Telescope captured an image of an extremely bright quasar, 3C186, located in a galactic core about 8 billion light-years away. Astronomers have long believed that a supermassive black hole resides at the center of most galaxies. However, a recent study of supermassive black holes has led to a shocking discovery. This particular black hole is not at the center of its galaxy. Instead, it is about 35,000 light-years away from the galactic core, farther than the Sun's distance from the Milky Way's center. So, how did a black hole more than 100 billion times the mass of the Sun end up in such a distant location? Researchers speculate that this could have originated from a colossal event, the collision of two galaxies 1 to 2 billion years ago. As these galaxies merged, the black holes at their respective cores began orbiting each other. Eventually, they merged into one, releasing an immense burst of gravitational waves. Due to asymmetric energy release, the new black hole was violently ejected at high speed. The impact was so intense that it was equivalent to the energy of multiple supernovae exploding simultaneously. Today, the black hole 3C186 is still drifting through space. It is moving at a staggering speed of 7.5 million kilometers per hour, tearing away from its parent galaxy. At this velocity, it could travel from Earth to the Moon in just 3 minutes. However, this ejected black hole, how massive is it? It's still a mystery. Black holes grow by devouring vast numbers of stars. But that doesn't mean they act like giant vacuum cleaners, actively sucking in everything around them. If a black hole with the same mass as the Sun were to replace it, Earth's orbit would remain unchanged. And since the radius of such a black hole would be just 3 kilometers, we would have to get much closer to be captured by its gravitational pull. Supermassive black holes are unimaginably massive, but compared to the true cosmic giants, black holes of extreme proportions, they seem almost insignificant. One of the most famous examples is found in the giant galaxy Home 158. At its core lies a monstrous black hole with a staggering mass of 40 billion times that of the Sun, more than half the combined mass of all stars in the Milky Way. Its size is so immense that it dwarfs our entire solar system. The Home 1.5 galaxy is located 700 million light-years away from Earth, and this cosmic behemoth remained hidden. It remains one of the largest black holes ever observed by humans. For a long time, scientists believed that an active black hole's mass was theoretically limited to about 50 billion times that of the Sun. However, a recent discovery has completely overturned that perception. In the universe, the brightest celestial bodies are not stars or galaxies, but quasars. These celestial giants are powered by extremely active black holes, outshining entire galaxies. Not long ago, scientists discovered a record-breaking quasar, TON 618. Its brightness is equivalent to the combined light of 140 trillion suns, so intense that it completely outshines its host galaxy. At the core of this quasar is a supermassive black hole, a colossus with a mass 66 billion times the Sun. Its scale is so immense, it exceeds the size of entire constellations in the Milky Way. The total mass of this celestial giant is unimaginable. Its event horizon stretches an astonishing 390 billion kilometers. That's more than 6 times the distance between the Sun and Neptune. TON 618 is located in the direction of the Canes Venatici constellation, a mind-boggling 10.4 billion light-years away from Earth. In other words, what we observe today is how it appeared when the universe was still in its infancy. And over billions of years, its mass may have grown far beyond our current estimates. But this raises a mind-blowing question. How did such a monstrous black hole come to exist? The scientific community has a hypothesis. A small black hole, acting as a seed, relentlessly consumed matter, until it evolved into a cosmic behemoth. However, computer simulations suggest that TON 618's formation doesn't quite fit this model. A more plausible explanation is that multiple black holes gradually merged over billions of years, forming this titanic cosmic entity. Despite this, we still don't fully understand the true origins of TON 618. Undeniably, it's the largest black hole ever found. And here's where things get even more mind-blowing. Scientists are constantly updating their understanding of. As our observations deepen, some scientists suggest that there could be an entirely new class of black holes. They're called ultramassive black holes, colossal monsters exceeding 100 billion times the Sun's mass, which raises the ultimate question. So one wonders, if black holes can grow infinitely, can they live forever? On human timescales, black holes are practically immortal. They do slowly evaporate through Hawking radiation, but at an unimaginably slow rate. For example, a black hole weighing 100 million tons would take the entire age of the universe just to lose half its mass. The bigger the black hole, the slower this process becomes. So even if all the stars in the universe burn out one day, black holes will continue to exist, drifting silently through the endless dark abyss of the cosmos. Thank you for watching. Don't forget to like, share, and subscribe for more space adventures.